what first caught your eye about this space and got you interested in working in this space?
Yeah, so I think going back to my undergrad, I think I did genetics, and at the time bioengineering was more biomechanics, biophysics. So I was really looking for something that was more interdisciplinary, and genetics was really big on sort of theory, and then a lot of the things that became synthetic biology or computational bio were originally home in these spaces. So I was always really interested in that sort of intersection of traditional biology and then all these other new digital tools. And I just wasn't aware of like the state of hardware. So I go into take my first job out of college, and I walk in and I'm noticing that we have all of these instruments, and it's just really exciting. I've always liked hardware. Was part of an aerospace club at Berkeley where we built our own planes, and so just kind of made sense to try to see how I could transition. And I think for a lot of people, traditionally in lab automation, you have two paths. Number one is like you are a engineer, let's say mechanical or something, who just happens to fall into lab automation, or you're a biologist who becomes an engineer. And so my path is the biologist research associate who basically was insistent on making this career change. So pretty much came in every day, asked questions, networked at my company, and really tried to fundamentally get to what we were doing, what were the tools that we were using, and how were these things being built. So pretty early on, I realized that this is a career you can have, and it's not something you'll get exposed to in undergrad necessarily, at least not at the time. But now you have programs, I think like Carnegie Mellon and others, that do like digital chemistry, that have automated sciences now, and so there's a subset of undergrads today who are graduating with a lot of that experience, which is really cool. Wish we had that, but I did it the old-fashioned way.
So it sounds like it's a field that, what drew your eyes, it's interdisciplinary, it plays with hardware, but it's one that people come into from something else. There's no sort of lab automation track. At least there wasn't when you were, coming up in school. Is that right?
Yeah, and what I really liked about it is, if you're somebody that likes to sit in between problems, right? You sit in between three of the biggest problems in the industry. There's the science, which you have to automate. There's the hardware, which you have to work with. And then there's the software, which you may have to build or interact with or scope out. And so lab automation really kind of sits at the intersection of all three, which is really unique in that sense. So I found that very intellectually satisfying.
Sounds like it would involve a lot of creative problem solving.
It is a lot of creative problem solving, and I think a lot of the really talented lab automation engineers that I know are very cross-disciplinary, very cross-functional in terms of how they work. And it is just, you're totally correct. I think it requires a lot of excellent problem-solving skills. And each problem is different, right? Sometimes you're optimizing for cost, sometimes you're optimizing for speed, sometimes you're optimizing for some other thing. And so I think all of those are considerations. So there's really isn't one form of lab automation. There's always going to be N+1.